Hey everyone. Okay, so in this video, we're going to be talking about integration by parts. So far you've done integration by substitution. So that's one technique. And now we're going to learn another technique where usually with these integrals, substitution usually doesn't work. So basically in by parts, unlike substitution, the derivative of one of the functions doesn't quite cancel with another function in the integral. And so you may or may not realize it at the beginning, but once you start using substitution, you'll realize that it actually gets you to a dead end where you have an integral that has both u and x's in it. So we're going to do an example now to see what that looks like. Okay, so for example, the integral of x e to the negative 3x dx. Now, if you realize the derivative, for example, of x would just be 1, and the derivative of e to the negative 3x would be e to the negative 3x times negative 3. Now, if you write those out, you'll notice that whether you let u equal to the x or to the e part, neither of those will cancel the other. So substitution wouldn't work here. So we're going to be talking about what by parts does. So what we do is you have to pick your u to be something, and then you pick your dv to be the other part of the integral. Now, usually this is the toughest part of by parts, is knowing which one to use. So we're going to do this example together. Now I'm going to give you the criterion on knowing what to let u equal to in dv, how to choose those. So for now, just for the sake of simplicity, we're going to pick u to be x, and we're going to pick dv to be the next part. So the entire part of the integral, whatever is left over. And now what we do is we say, okay, what's the derivative of u? So the derivative of u is just x, so the derivative is just 1 times dx. And on the other hand, dv is already a derivative, so we're just going to take the integral of that to get v. Notice here, u, we take the derivative to get du, but for dv, we already have the derivative. We're going to take the antiderivative to get to v. Now, the antiderivative of e to the any number x is just always itself divided by the number that appears in front of x, or in other words, the derivative of the exponent. Okay, so now that we have that, we're going to use the formula u times v minus the integral v du. This is the formula for by parts. I'll give it to you in another screen as well, but just so we have it now. So what we're going to do is we're basically going to sub in our values or our functions. So u is x, v is e to the negative 3x over negative 3, and then minus integral of, and then v would be e to the negative 3x over minus 3 dx. Okay, so there we have it. And now we're going to actually evaluate the integral. Okay, so now I'm just going to go to the top of the page here. We still have the last line right there, so I'm going to continue from there. If I simplify over here, it's an x over 1. So if I'm multiplying fractions, I'm getting x e to the negative 3x all over negative 3. And then the other part, be careful here because you've got a minus right there, and then you've got another minus in the negative 3. Those become a plus. So we're going to have plus. I'm going to pull out the factor of 1 over 3 to the outside. Otherwise, it makes the integral look difficult, even though it's all right to do. Okay, and then we just get x e to the negative 3x. The negative 3 stays there. And then we do plus 1/3. And now this integral, again, what we're asking for is the antiderivative of e to the negative 3x, which we know is e to the negative 3x over negative 3. Okay, we just did that earlier. And then plus c. And now we just need to simplify a little bit, and then we're done. Okay, so just right now, I'm just going to simplify it once more, and then we're pretty much done. So the first part stays the same. The second part, you've got the 1/3, and then you've got the negative 1/3 here in the denominator. So again, that plus and that minus will become a minus, and you're going to get 1 over 9. The 3's multiply, and then the e to the negative 3x plus c, and there it is. And that's the answer. Okay, so I promised during the other question that we would go over this. So we'd need some sort of criteria on how we would choose u and how we would choose dv, because if you pick the wrong one, you're going to end up potentially getting to a dead end. So you want to make sure that you choose the right u and dv right from the beginning. Okay, so I'm going to give you a criteria. It's going to be an easy acronym to remember, hopefully. All right, so here's an acronym. So we're going to use acronym LATE, and this is the order in which you choose your u. Okay, so if the integral has, for example, logs or lns in it, then you choose your u to be your log or ln part first. Okay, and then you let your dv be the rest of the integral. If your integral doesn't have any logs and lns, then you choose your u to be the algebraic function that you find in there. So algebraic, I mean, for example, powers of x or roots of x. So either powers of roots of x, like let's say x to the 1/3, root x, whatever it might be, anything like that. Okay, if your integral does not have either of those, then you choose your u to be trigs, so trigonometry. So let's say sine x, cos x, and so on. Now, your course may or may not do trigs for integration. So if you're not doing trigs, then you can just simply skip it. And then lastly, you would choose u to be your exponential functions. Okay, so for example, e to the negative 3x like we just did, e to the negative x, e to the 10x, whatever it could be, any exponential function of that sort. Okay, now let's do another example. And in this one, we're going to practice using that acronym. Okay, so we've got the integral ln of x over x squared. And here, what I would suggest to do by parts, you always want to have a product of two functions because it's almost like doing a inverse product rule. So rewrite this as ln of x times 1 over x squared dx. If you write it like that, then it's clear. My ln of x is the first function, 1 over x squared is the second function. Now, in the acronym LATE, we said if you have a log or a ln in your integral, then you let u equal to that. So just look at the integral. Does it have a ln or log? Yes, it does. It's right there. It's the ln of x. So we're going to pick u to be our ln of x. Okay? And then our dv is going to be the rest of the integral, which is 1 over x squared dx. And I would suggest right now, I know I'm going to have to take the antiderivative anyway, so I might as well change it to x to the minus 2 dx. And remembering the other one, we did the derivative of u, which is the derivative of ln, which is 1 over x dx. And for dv, we're going to do the antiderivative. I would take it from the x squared part right there. It's a little bit easier to integrate than the 1 over x squared. And that, remember, I add 1 to the exponent and then divide by that exponent. Okay? Alrighty, so now that I have that, just as a reminder, our formula for by parts is again uv minus integral v du. You want to make sure you memorize that at least for the test and the exam. So now we're just going to sub them in. So I'm going to get u, which is ln of x, and then times v, which we have right there, x to the negative 1 over negative 1, and then minus integral of v, which is x to the negative 1 over negative 1, times du, and our du is 1 over x dx. Okay, so there we have it. Now, of course, we need to simplify that, so we're going to do that at the next step. Okay, so continuing right up there, just so that you can see it, I'm going to bring this up, and we're going to go right there. Okay, let's see. So right here. Okay, so I'm going to simplify this right now. We might as well do it as we're going along. So ln of x stays the same. And then times, now the negative 1 in the bottom, I would bring it to the top. It doesn't matter. It's a fraction. X to the negative 1, I would write it as 1 over x. Okay, you don't have to, but it does make it look a little bit better. Now, look at the bottom right here. There's a minus right there, and there's a minus 1 right there. So they combine to a plus. So I'm going to change that to a plus. And then I've got the x to the negative 1 times 1 over x. So the integral of, I'm going to show all the steps here. You can just skip through if you don't need to see the steps. But there it is. Okay, now at the top here, I'm going to just, the minus comes to the front, so I'm going to get minus ln of x over x, because you could look at it as ln of x over 1 and just do fraction multiplication straight across. Okay, and then this is plus, and now this is exponent subtraction, so we're doing -1 -1, so we're getting x to the -2 dx. Okay, alrighty, so this becomes minus ln of x over x, so that's okay. And then remember, we have to integrate this, find the antiderivative. Antiderivative is not too bad, just add 1 to the exponent, divide by that, and then add a c. And finally, I'll just continue right underneath it. So this is minus ln of x over x. Again, this is just like we did at the top. We're going to do minus, that plus and the minus become a minus. And then the x to the -1 can go to the denominator. And we're going to have plus c. And there's my answer right there. Alrighty. Okay, let's do one more example here. So in this case, I've added one more condition, which is these, the 1 and the 2. So basically bounds for the integral. We're going to practice with those as well. So in this case, again, it is by parts, and we've got two functions. There's t minus 1, and then there's a e to the 1 minus t. I consider that e to the 1 minus t as one entire function. Now we need to choose our u and our dv. So again, according to that acronym, even if you can't remember the acronym, by the way, you can still pick your u and your dv. The other trick really is to pick your u to be the function that has the easier derivative, and then your dv to be the function that has the easier integral. That's a little bit harder to for most students to remember, so that's why I give that acronym. But if you're finding it difficult to remember, then you can use that other trick as well. So in this case, and again, we go according to the acronym. Do I have any logs or lns? No. So then I skip to the next one. So my u is going to be dependent on whatever I have in this order. I don't have any logs and lns, so I'm going to go to algebraic. Algebraic means powers and roots of x or t. In this case, yes, we're good to go for algebraic. My t minus 1 is considered an algebraic function. And notice that in the acronym comes before exponential functions, which is all the way at the end. So that's how I know I'm going to pick my u to be t minus 1. And then the rest is going to be e to the 1 minus t dt. And then we're going to take it from there. So again, just like before, my du is just a derivative, which is 1 times dt. And then v is going to be the antiderivative of dv. Okay, the antiderivative, this one might be a little bit confusing, but e to anything usually is just e to the whatever you have in the exponent, divided by the derivative of the exponent, provided that whatever is in the exponent of e has a derivative that's a number. So let's say in this case, the derivative of the exponent is minus 1. So I could use the rule that the antiderivative is just copy and paste the e to the whatever you have, and then divide by the derivative of the exponent, which in this case is minus 1. Okay, so again, remember the formula uv minus v du. So I'm going to rewrite it quickly here, and we're just going to sub it in. So u was t minus 1. Now be careful, because here we have bounds to evaluate. So I'm going to, oops, let me just undo that. But we do have to evaluate at 1 to 2. So my u was t minus 1. My v is e to the 1 minus t divided by -1. And I'm evaluating this from 1 to 2. Okay, and then minus the integral from 1 to 2. And then v du, so e to the 1 minus t all over -1 times du, which is 1 dt. The 1 is redundant, so I'm just going to write dt right there. And we're going to continue at the top. Now, before doing any sort of evaluation in these integrals, I would definitely simplify first. Okay, so if I'm just going to continue right up here, so we have the rest of the question. That -1 underneath the e, I'm going to bring that to the front. So I'm going to have minus t minus 1 if you want. Now, I'm just going to change this right away, because if I put the minus here, I'm just going to bring it back in right there, and everything's going to change sign. So instead of having it too complicated, I'm just going to undo that and basically bring that so that I get 1 minus t instead. Okay, and then the e to the 1 minus t. And now I'm evaluating this from 1 to 2. And then minus, now again, there's that minus right there. and then there's a minus in the denominator, and those turn into a plus. So I might as well do a plus right now. And then integral 1 to 2 e to the 1 minus t dt. Okay, we're getting there. This one I'm gonna leave as is. I'm not gonna evaluate yet. We want to evaluate everything together. Okay, this is plus, and again we're doing antiderivative of e to the 1 minus t. So e to the 1 minus t, we've sort of already done that, so we know the antiderivative. Evaluate it from 1 to 2. Okay, so continuing this onwards, now you can evaluate. Remember that you're subbing in the top number first and then the bottom number second. So I'm going to do 1 minus 2, e to the 1 minus 2, minus 1 minus, hold on. Let me just undo that. Oopsies. 1 minus 1, e to the 1 minus 1. So that was for this part right here. Okay, and then I'm going to do plus e to the 1 minus 2. I'm subbing in the 2 again before. And then minus, when I sub in the 1, a lot of these things are going to cancel, which is kind of nice. So 1 minus 2 is negative 1. So I'm going to get a negative e to the, and 1 minus 2 is minus 1. And then minus, this part here is going to become 0. So I guess I could write it as minus 0, but at the end it's going to go away. And then the next term is going to be again that plus right there, and the minus are going to become a minus, and then you're going to get e to the negative 1. And then, okay, be careful here. I've got a double minus, so I've got a minus right there, and then 1 in the denominator. So basically, it's going to become a plus. And then e to the 0 is not 0, it's 1. So just be careful for those on the test. Then I'm going to get, okay, so I've got minus e to the negative 1 minus e to the negative 1. That's minus 2e to the negative 1. The 0 is gone, and then you get plus 1. And there's the answer right there. Okay, one final example to make sure that you understand this very well. So you've got integral ln of x dx. Now, usually some sort of variation of this question comes up on almost every test, so I wanted to make sure I don't ignore that one. The thing that makes it tough is that it looks like there's only one function. And so far, for by parts, we've had 2 functions, and you could pick one for your u, pick one for your dv. We only have one function here. It looks like we only have one function, but what if I write it as ln of x times 1 dx? What if I write it like that? Then you could look at ln of x as your first function and the 1 as your second function. Okay, now here's where the acronym comes in, again, late. Okay, so I'm going to pick my u to be, let me write it here, dv. So I'm going to pick my u to be in the order that I have it here. Do I have a log? Yes, I do. So now I'm going to let u equal to ln of x. My du is going to become 1 over x dx. That's a derivative of ln. And then the dv, you have no choice. It's the rest of the function, which is 1 times dx. Okay, v is equal to, now be careful. Again, people sometimes forget that this is the simplest of the antiderivatives. The antiderivative of 1 is x. You have to think of the derivative of what gives me a 1, which is x. Okay, so I'm going to skip right in the formula. By now you have the idea. So uv, so I get ln of x times x minus integral v du. So that's x times 1 over x dx. Okay, this one is not too bad actually, but it's that first step of knowing what to let u and dv equal to. I'm going to bring, let's undo that. I'm going to bring the x to the front. So I'm going to have x ln of x minus the integral of, now notice the x times 1 over x. This is like saying x over x dx, which instead of writing x over x, we can just do 1. So I'm just going to skip that step here and just write 1 dx. Okay, and then we get x ln of x, that stays the same, minus, and again, we're doing the antiderivative of 1, so that's just x, and then plus c. And there is the answer. Okay, so I hope in this video you've learned how to do integration by parts, and hopefully I've given you some tricks that work. So hopefully it's a little bit easier for you. Now it's your turn. I would suggest going to your textbook and doing as many questions on by parts as you can. The best way to learn this technique, and it's the same with any other technique in math, is to do as much practice as you can on your own and then compare. And if you have to work with friends and classmates, by all means. Okay, good luck.